Alright, here is the next set of notes on the sum intense problems. So this time what we're going to be doing is we're going to be changing the distance that the emitter is from the listener. So in this case we have bees' wings that are emitting an intensity level of 45 decibels from a distance of 10 meters, and we want to know what that intensity level is from 1 meter. Well, we can actually solve this particular problem without doing any math. We think conceptually about what's going on. If you notice, what is our distance doing from 10 meters to 1 meter? Well, it's decreasing by a factor of 10, which is going to do what to your intensity? If you remember from a notes a couple days ago, that intensity decreases with the square of the distance. So if we're getting 10 times closer, then our intensity is actually going up by 100 times. So if our intensity is 100 times more than what it was, how does that affect the intensity level? Well, if you look back at your chart from the first day of notes, you'll notice that if we increase the intensity by a factor of 100, or 10 to the 2, intensity level goes up by 20 decibels. So in this case, if we start at 45 decibels, we'd increase by a factor of 20 decibels, and we'd go up to 65 decibels. Again, you could do that without math, but we're going to be using math to solve this. So using mathematical way, we first want to take the intensity level and convert it to an intensity. If you remember, you can start from this equation right here, and then substitute in your values. There's your 45 decibels going in right here. So this is the intensity at 10 meters. So now we need to find the intensity at 1 meter. So again, using this equation here, we're going to find the new intensity. So it's going to be the intensity that it currently is times 10 squared divided by 1 squared. And you notice that it goes up by a factor of 100, which is what we said. So again, it goes from 10 to the negative 8 to 10 to the negative 6. Now once we have the new intensity, we then are going to find the new intensity level. So again, plug it into this equation, and that answer, which you can't see, is 65.0 decibels. Sorry about that, it got cut off from my screen. Maybe you can see it there. Hopefully that captured it. So again, you can pause the video at this point and then write down that information with the problem that you need, and then once you're done you can restart it. Alright, moving on to example number 2. Here we have 50 mosquitoes. There's the intensity level of 50 from that distance. Now we're going to go to 220 mosquitoes at a distance that's closer. So this one we need to use math to solve. We can't just solve it from a conceptual standpoint. So the first thing, again, I need to take my intensity level and convert it to intensity. So again, you can start with this equation right here, is fine by me. Again, this is the intensity of 50 mosquitoes that are 8 meters away. So I need to find the intensity of one mosquito that's 8 meters away, or of 220 that are 8 meters away, and then get my distance as well. So this goes from 50 to 220. So again, you can multiply by 220, divide by 50, and then I need to then go to a new distance. So I have to use this equation here, solving for my new intensity. It's IR squared divided by R prime squared. So this is the original distance, this is my new distance, and that's going to give me a new intensity. You can see, make sure you square your distances here so you get the correct answer. So this will be the new intensity of 220 mosquitoes at 3 meters away. And again, it should be greater than what it was at 8 meters away. So you can see that that exponent is a smaller number, or a larger number, I'm sorry. It's a smaller negative, which makes it a larger intensity. Once we have our new intensity, we can then solve for the new intensity level. Again, pretty straightforward at that point. Again, hopefully this makes sense conceptually why we have to go through this process. Again, the things that are additive are the intensities, not the intensity levels, and then we have to sprinkle this equation right here in when we change the distance away. again, pause if you need to so you can write all the information down and then continue when you're ready. Example 3. Here we have a dog's bark. Its intensity level is 80 decibels from 5 meters away. We have 4 dogs that are barking. One is from your neighbor that's 25 meters from you, and 3 are across the street at 100 meters from you. And we want to know what's the perceived intensity level when all 4 of these dogs are barking. So again, this one's again a little bit more of a challenge because of what we're dealing with. So I want you to kind of think about it and then we'll discuss it. So pause the video, think about what you're going to be doing, and then we'll talk about what you'll do. Okay, so here's kind of how you're going to proceed. We have an intensity level. We're going to convert that to an intensity, but again, that's an intensity at 5 meters. We need to find the intensity at 25 meters and also find the intensity at 100 meters. This will be the intensity of one dog at 25 and one dog at 100. We then need to multiply this one by 3 since we have 3 dogs at this distance. To find the overall intensity, we need to then add those two together and then find the intensity level from it. So that's kind of the way that we're going through this problem. Here's the intensity of one dog. This is the intensity of 3 dogs. And these are 5 meters. We then need to go to 25 meters for the one dog and 100 meters for the 3 dogs. So here we're going to find the new intensity for the one dog at 25, and here's the new intensity for the 3 dogs at 100. And again, those should decrease. And you can see that those intensities decreased from their original values. We then add to find our total. And again, when you add to get significant digits on your addition rule here, you have to have the same exponent. So we move this one more spot to make it 10 to the negative 6th, and now you can see we have 1 decimal, 2 decimals, so my answer is only going to have 1 decimal that's significant there. 2 significant digits in my answer, so my intensity level will have a 1s digit and a 10ths digit, very similar to what it is up here. And you can see that there's my final intensity level from the dogs that are barking. So you notice that 4 dogs are actually less intense, significantly less intense than one dog that's 5 meters away. Again, because it varies with the distance, so those dogs are fairly far away. They're not going to be extremely loud in comparison to the one dog that's pretty close to you. That's it. Your homework is going to kind of follow this particular pattern in terms of the type of problem. There's only 3 homework problems tonight. Again, you can refer back to this PowerPoint or this video as you see fit. Thanks.